Okay, in the previous class, we are talking about what are different types of autonomous vehicle technology we are trying, correct? Special road laying, special road platooning, correct? And this electronic tow bar, all these things are tried. Finally, they come out with only way to solve the road accidents, improve the traffic efficiency is to have a vehicle driven by a computer with a proper algorithm and is a vehicle installed with various sensors which can monitor the environment here, road environment. Then the sensor data will be processed by computer and it will drive the vehicle by controlling engine, steering system, and brakes and transmission system. These are the four fundamental elements of any vehicle that should be controlled by a computer instead of human driver. And the vehicle should be intelligent enough, like a human driver, right? Or the control algorithm should be intelligent enough to drive like a human driver in any environment. There's no possibility of building special roads, correct, or allotting special lanes, correct. AHS is building special roads with sensors buried underneath, and so that the vehicle with sensor, onboard sensor, it can drive itself. Correct, special road not possible because of the many issues like social info, getting info, road space, correct, and environment is cutting lot of trees, all those things. All those, because of that, even though it was feasible, demonstrated using path program and other programs around the world, it was abandoned because not feasible. Then they said allocating special lanes within the available road itself, correct, BRTS, correct. The BRTS, all those things, that also there's already you have limited lanes, 3 lanes, 4 lanes, like that, even in highways, correct. You cannot allot existing lanes to autonomous vehicle and remaining for regular vehicle because we have more regular vehicles, billions of vehicles already there. The lifetime for most of the vehicle around the world is 15 years. Because most of the government given, yeah, new vehicle is not, it should be allowed to travel in the road at least minimum 15 years. We have paid road tax. So we have billions of regular vehicle mandated. You cannot abandon them and force them to go in only existing lanes is not sufficient. Right? 4 lanes we are getting traffic. That's why we are going to the autonomous vehicle. So allocating special lanes within the existing road also not possible. So then finally it was concluded year 2000 that one day way is to have the vehicle which can drive itself like a human driver, that means computer, hardware, sensors and software algorithms using artificial and all those things, which can drive like a human driver in the regular roads, correct, which is called a mixed traffic. That means the vehicle, the controller should be able to drive vehicle in any situation, any road, anywhere, like a human. That's what they try. So the examples already said, first vehicle to be come out with such capabilities, the Google car, which was demonstrated from 2009 onwards. Subsequently, Tesla is selling cars and all other companies. I'm not saying that all the companies, we saw the many, Toyota, Ford, GM, BMW, Mercedes-Benz, Citroen, every company, Indian companies also trying. We know that they are trying with the research. They are trying to come out with their own autonomous vehicle. It will come soon, correct? So now we will go to the how to make from today onwards. We are going to see how to make a regular vehicle, correct? Whether it is a first we will start with regular fossil fuel based IC engine based vehicle. We are not going to talk about electric vehicle. Electric vehicle, I am teaching separate course. Of course, not often. Maybe next year we will offer hybrid and electric vehicle. Correct. In this course, we will be talking about making the IC engine based automobile into a autonomous or intelligent vehicle. Correct, which can drive in any road just like human driver. So for that, the first step is making the each and every component of or subsystem of the vehicle which can be controlled electronically, correct? Because later the autonomous vehicle is controlled by a master controller, a computer which will process data from the lidar, radar, camera, ultrasound sensor, all these things, and based on that it will look for the lane marking, road signals, obstacle, all those things, and it will generate control signal for engine to accelerate or decelerate, brake to stop the vehicle, or steering control to steer the vehicle appropriately, correct, in the lanes. Then of course transmission system sometimes may have automatic gears, so it will control. So that is the field. So now we will see how the make these four elements: engine, brake, steering, and transmission system to be controlled electronically. Correct? Because for last 70, 80 years or 90 years, all the vehicles, IC engine based vehicle, even electric vehicle, the initially which were tried, were based on the human control. Correct? There were levers, correct? Gear lever, then acceleration pedal, brake pedal, steering wheel, which has we have to give force. Correct? Maybe a linear force or circular force, which you call a torque. The steering wheel give, then through which the human driver control. Now, since we want to electronic control, first thing is we make this subsystem into electronic controllable. So today we are going to see how to make the regular conventional IC engine based vehicle to electronically controllable. Okay, so this figure shows that the electronically controlled vehicle, which is presently available for last 20 to 30 years, more than 30 years. Correct? So the automobile engineers across various companies and researchers across various universities around the world have started to make vehicle electronically controllable from 1960s itself. First thing, they started with controlling engine, which is called fuel injection. Correct? So engine is controlled electronically. We call it a fuel injection. Instead of, first thing is engine control, which is electronically controlled. Correct? Electronic fuel control or fuel injection. Correct? Which injects the fuel quantity such that the engine generates sufficient torque as per the driver demand. What is the driver demand? Driver demands the engine to produce more torque so his vehicle can accelerate from standstill to some maximum speed what is allowed by, or which engine can produce. That is by injecting fuel into the combustion chamber appropriately. Correct? So main important appropriately. Appropriately means in petrol engine you have to maintain air fuel ratio, which is called AFR. Correct? AFR is air fuel ratio. We are going to see now. So air fuel ratio should be maintained in petrol engine. Correct? Similarly, in diesel engine, we never say the air fuel ratio. The torque generated by petrol engine or the torque generated by engine, torque by engine, generated by engine is proportional to fuel quantity. Fuel quantity injected. Fuel quantity injected inside the combustion chamber. Inside the combustion chamber. There's a one main thing, correct? How much fuel you can inject, that depends upon fuel quantity. Fuel quantity is controlled by or is controlled by amount of air trapped inside the combustion chamber. Trapped inside combustion chamber. That decides, correct? So already we are going to see that. In case of air fuel ratio means, because we talk about petroleum and stoichiometric air fuel ratio, that means if 14.7 gram of air is trapped inside the combustion chamber and of the suction stroke, you can inject 1 gram of fuel. That is called stoichiometric. In diesel engine, we never talk about the stock. Instead of that, we say the torque demand. Correct? If you inject more fuel, more torque will generate. So that we can decide. There also you cannot inject too much fuel. Correct? Then fuel will be wasted. We will see how it is. So first thing is you have to make the engine electronically controlled using electronic fuel injection. Correct? Then you have steering system. Correct? Next is steer the vehicle. Steering the vehicle is done by assisted steering. Most popular is assisted steering, already available in the most of the vehicle for last 40 years. Fuel injection is there, electronic fuel engine 1970s onwards. Correct? 1970s onwards in all American companies. Correct? In US, whether it is a Japanese company started, whether Toyota is a Japanese company, but they have factory in US, or they can export or import vehicle from consumer at US can import vehicle from any country. Correct? So any vehicle sold in US in 1970s itself, they started using a fuel injection. okay, to reduce the pollution and also increase the drivability, correct, better response. So the 1970s, but in India it came very late, around to 1996, approximately 2000 only, the fuel injection. Before that, even most of the cars, even in up to 2000, were carbureted, correct? The fuel quantity controlled by carbureted. But now we know that all vehicles are fuel injected, correct? Now even motorcycles are coming with fuel injection. Next thing is assisted steering, correct? There are two types of assisted steering, correct? Electric assisted or hydraulic assisted. Hydraulic assisted. There are two types of steering assisted. Here means there's a steering wheel. When driver tries to turn the vehicle left, when he turns the wheel, correct? So you have a steering wheel, correct? When it is turned right, there is a motor inside the attached to steering column, correct? There's a motor which is attached to steering column. It assists the driver who is turning the vehicle normally. The driver is turning steering wheel, correct? Left means right, whichever way you wanted to steer the vehicle. When he tries towards right, there's a motor which gives torque assisting the driver, correct? When you want to turn the vehicle, you have to give a torque on the steering wheel, correct? So that torque depends on vehicle weight, correct? Say a vehicle is 1 ton, correct? Small vehicle, 800 kg, 1000 kg, correct? So the torque needed will be less. If you go to bus, which is 5 ton, then more torque has to be given for steering the vehicle, correct? Generally, front wheel steer, correct? Most of the vehicles are front wheel steer. Generally, still now. Now we know that there are some vehicles which 4-wheel steering also, all-wheel steering, correct? But 99% of the vehicles now available are sold, including latest cars, are front-wheel steer. That is controlled by steering wheel. This is, you have the steering wheel. Steering wheel, when the driver turns right, the vehicle turns right. When driver turns towards left, the vehicle towards left. That time, if they most of the time it was manually steered. Manual steer means if you have to give a steering torque, correct? You have to give torque, correct? The torque is proportional to weight of the vehicle. Weight of the vehicle, correct? So if vehicle is small, the torque needed to turn the vehicle is less. That means steering torque, we call it steering torque applied by the driver, correct? Is a human. That's why most of the human, now only we are going autonomous vehicle, correct? So human, even previously up to 1970s, 80s, it was steering is torque is given by driver only. Later they found that when you have sharp turns and when vehicle is big, correct? If vehicle weight is more, correct? Say for example, 10 ton truck, 20 ton truck, correct? Bigger trucks, all those things, earth moving vehicles, correct? Which is working in mind. Then the torque given needed by the driver to turn vehicle is more, correct? Then quickly driver will get tired. So they have put one assisting motor, correct? This is called assisting motor. Assisting motor, correct? Assisting motor they have provided that will be coupled to the steering column. This is the steering column. When driver turns right, the motor also will rotate and give torque to assist the driver to moving towards right. When driver towards left, there's a sensor which measures what direction driver is trying to rotate, correct? So steering wheel angle sensor, that is called, we are going to see it, but correct? So that is going to be controlled. So that will make the motor to move right or left in the same direction as the driver is trying to turn the steering wheel. So these are assisted steering. Generally, for example, if you need 10 Newton meter torque to turn your vehicle manually, correct, up to 8 Newton meter, we say that 80% or 90%, it can be individual vehicle design, the manufacturer designs, correct? Generally, 80 to 90% of the torque will be given by this assisting motor, which is attached to steering column, correct? Remaining 20% or 15% torque only will be given by the driver. So that means the driver need not exert himself too much, correct? So now driving become easier, correct? You bigger vehicle also easily you can turn without much effort, correct? So that is called steering. So that will, since there's a motor, there's a sensor which measures what direction the driver is turning the wheel, which wheel, steering wheel. Accordingly, the sensor, the steering assist system. There's a sensor which has steering angle sensor or steering angle rate sensor. We will see that later. Correct. That single will go to an electronic ECU. ECU, which in turn will turn the give power electric motor. This motor can be electric motor, as I told you, or it can be hydraulic motor. Correct. The steering assist motor can be electric or hydraulic assist. In smaller vehicle, generally it is electric because easy to implement all those things. But in a bigger vehicle, truck, multi-axle, all the where vehicle heavy, you need more torque. Generally, it will be a hydraulic motor, correct? Hydraulic motor, which will be controlled electronically, correct? That's how it works. Then third thing, that's what a steering system, assisted steering. This case. Now we have what you call a steered, fully electronically controlled. There's no mechanical linkage. We have what you call steered by wire. There's a steering wheel, but there's no steering column, correct? Well, there'll be like a video game, there'll be a steering wheel. You turn wheel left and right. Below the wheel, there's a sensor which measures what direction the driver is turning. Then that signal goes to the ECU, and the ECU will in turn control the motor connected at the front wheels, correct? Where steering has to be there, or that can be common. That is called steer by wire. We will see what it is. So, correct? Steering assist is possible or steer by wire. There both are there. Correct? Steer by wire is there's no steering column. Steering assisted means, as I told you, there's a steering column by which there's a motor. We will see what it is. Correct? So steering. Then you have brake system. Correct? Brake is you have what you call ABS. Correct? You have ABS. That is nothing but anti-lock braking system. Anti-lock braking system is short form of ABS system. Correct. This brake is electronically controlled. Correct. It is electronically controlled. When driver presses the brake pedal, correct, depending upon normal this one, there's a mechanical linkage. You apply force, the force is connected to wheel. There's a brake shoes put on the wheels that will be go on, press the against the rotating wheel and stop this. That is correct. That is manual. Correct. There you have to give more force. If you want to if your vehicle is going fast, if you want to stop quickly, you have to press more force. You have to apply more force. We call hard braking. Correct. So if your vehicle is going say less speed and you wanted to stop slowly, then you can do less force. That means by applying the amount of force applied by the human driver using his leg, besides the braking force. But in ABS, there's an electronic sensor which measures the wheel speed and whether wheel is rotating or not, and accordingly that sensor signal is given to an ECU. Correct? ABS has another ECU. ECU receives the signal from wheel speed sensor. Correct? It is called wheel speed sensor. Correct? Wheel speed sensor gives a signal whether wheel is rotating or stop. Correct? Brake. What do you use a brake? You have to stop the vehicle. Correct. So if wheel is rotating, that information goes to ECU. ECU in turn will apply give electric signal to the actuators. Correct. Generally hydraulic servo valves, which will allow the hydraulic fluid to apply brake force. So ECU control the brake shoes. A brake mechanism, which can be mostly these hydraulics. So hydraulic brake to mechanism, the valves are controlled using electronic control unit. So the vehicle will be stopped or made allowed to go. If you take your foot out of the brake pedal, the ABS system will allow vehicle to brake shoes to release the wheel to rotate. So the vehicle moves. When you press, it does. So that is called ABS. Again, it is an electronically controlled anti-lock brake system. Correct. Then suspension system will be there, automatic suspension. Correct. Active suspension. Correct. We will see what is active suspension. We'll see that. Then of course the transmission control also possible. Correct. There can be a transmission, electronic transmission. We know that the gear change, automatic gear. So these are the possible things we have to see when you want to make the vehicle electronically controlled. That means first the mechanically controlled brake shoes. Correct. Steering system, or engine, or the transmission system should be electronically controllable. Okay. So now, first thing we start with electronically controlling the engine, electronically controlled engine. Correct. For one by one, we see how to make the engine generally mechanical control into electronically control. If you see an electric general IC engine, correct, you have the engine. Correct. You have engine. Engine is connected to through gearbox. Correct. You have gearbox connected to wheels. For example, front wheel driven vehicle, correct? This is gearbox. Sorry. Gearbox through which it goes to wheels, correct? This is back wheel. For example, I can say that this is my back wheel. This is connected to chassis, front wheel. My engine is there. Okay. Now, what do you generally most of the engines, correct? If you see the engine system, you have the engine, correct? And you have fuel tank. From fuel tank, fuel comes to one device called carburetor, correct? Fuel comes to carburetor. Carburetor in turn allows the fuel go inside the engine. Along with this is carburetor, correct? Along with this, the air is also entering, atmospheric air. Air from atmosphere is entering. This is air filter, correct? So from air filter, this air is entering into engine, correct? So now when air is entering from engine, from carburetor fuel, in fact, this air will not go like this. It goes inside the carburetor. Okay, I will modify a little so that it will be easy. Okay, this is my engine. You have carburetor. This is connected to fuel tank. Fuel is coming, air is entering, correct? So air is entering here. Of course, there will be air filter. Many times, definitely there will be air filter. So remove dust particle, air filter, and this is the atmosphere. Air is entering here, correct? From atmosphere, and air filter filters the dust, and this will go inside the carburetor, correct? Air will go inside the carburetor. I am using different color. Air is from here, it enters the filter, and a filtered air will go inside the carburetor, and here the fuel is get mixed, correct? Fuel is get mixed, and then here the air and fuel is mixed, which is called as air fuel mixture. Air fuel mixture enters into the engine and combustion takes, correct? This is the combustion chamber. Correct. So what is the job of the carburetor? Carburetor is called as fuel metering. Carburetor job is preparing air fuel mixture. Correct. This is the conventional petrol engine. We are talking about petrol engine here. Correct. So we are talking about petrol engine or gasoline engine. Correct. In US they call gasoline. In British Commonwealth country is called petrol engine, including India. Correct. So this is what it. So here this picture, correct. The car, what is carburetor? It prepares the air fuel mixture depending upon the driver demand. Depending on driver demand. Correct. How the driver demand happens? When you press, when driver presses the accelerator pedal, correct. The car in the carburetor, the system I am going to show here, then it makes the fuel to more fuel to go inside the cylinder. Okay, here you can see that this is a carburetor, typical carburetor figure, correct? This figure is the carburetor, correct? It has many parts, correct? So you can see that there are two. This is the carburetor. This part is the carburetor, correct? This carburetor is carburetor. This one you can see the air filter is here, correct? From atmosphere, correct? Air is entering into air filter. Dust is removed. Then in the conventional vehicle, you have two valves. One is called choke valve. Other one is called main valve, correct? Or butterfly valve. This is called as butterfly valve. It looks like a butterfly wings, correct? That's why you call it butterfly valve, correct? So when this butterfly valve is connected to, this is connected to, one minute, we remove most of things, right? So this butterfly valve or throttle valve. Generally, they say nobody using butterfly. You say that throttle valve, correct? That's why it's a throttle valve is connected to the accelerator pedal, correct? When accelerator pedal, when driver press accelerator pedal, the butterfly valve will be open. Okay, so it will be, now you can see that it is horizontal. Sorry, vertical it is there. So now the because air is entering, correct? This is the pipe, right? This is called a plunum or manifold. In fact, called as air manifold, correct? It is nothing but a pipe, correct? It's a pipe, correct? You can see that this is a pipe with having some diameter, correct? So one end the air filter is connected, other end is connected to engine. Here it is connected to engine inlet valve. Inlet port, it is connected to inlet port, correct? So that means it goes. Now inside the carburetor, you have a reservoir which is here. You can say that this is the fuel tank. Fuel gas is nothing but petrol. In US they call it gas, correct? It is not like a gas, correct? Air or any other gas. It is, in US it is called gasoline engine. Petrol is called as a gas. So simply they call gas. Correct? Don't get confused with methane gas or something like that. Other gases. So petrol also called as a gas in US colloquially, correct? They call it gasoline engine. Short form is gas. So this is fuel tank. From fuel tank, petrol is coming and it is get collected inside the carburetor. It has a reservoir. You can see the petrol is filled here, right? And there's a float which controls the amount of the fuel, because otherwise fuel will overflow and come out. So there's a float and a small valve, correct? There's a small valve, which this is a valve. Valve maintains the fuel level, inside the carburetor, so that no overflow. You have to maintain a constant amount of the petrol filled inside this. You can see that it is in orange color, correct? So it is in orange color. That so fuel is filled. Then you can see that this pipe, correct? This is what I call the plenum or manifold. Is a manifold is a pipe, correct? But the pipe, you can see the from here top to here there is a one diameter. For example, say 10 mm. For example, say 20 mm, make 10 mm, 20 mm something, correct? Small engine, correct? Then you can see that there's a restriction. It comes like this, correct? Suddenly the diameter of the manifold reduces near the carburetor, correct? So near the carburetor, again it becomes same as the upper, say here both the place 20 mm, here it can become, for example, 10 mm. So you can see the restriction, correct? That creates what you call a Venturi effect, correct? That creates Venturi by, Bernoulli's equation. Bernoulli's this principle, correct? So now whatever this is connected to engine, inside engine, correct? So inside that, this is the cylinder, engine cylinder. Engine cylinder. Inside that, there's a piston, correct? This piston is moving up and down, correct? So the piston is, this is the piston is moving up and down, correct? It can move reciprocating like this one. So when piston is going down, because it's tightly enclosed, right? So when piston is going down, there's a vacuum, correct? This is called combustion chamber. Combustion chamber, correct? So when piston is in upward position, very small volume, correct? When piston moves down, this volume increases. Combustion chamber volume increases, correct? Inside, okay. But that means there's a vacuum is created. Because only way the air can enter is only through this one. Through this it can enter, correct? So when vacuum is created, automatically there's a valve here. This is called the inlet port. Inlet port of IC engine. there's a valve. The mechanism is not shown here. I will show in subsequent. The valve opens, so the air outside will try to go inside the engine. Correct. So through air filter, through this plume, it enters. When it is going, because here you have a restriction, correct? Venturi is there, correct? The diameter changes. There's a pressure difference happens. Correct. So when the path become narrow, the pressure increases. Again, the path become wider. Correct. So there's a vacuum is created. In Venturi, there's a vacuum is created. Correct. When vacuum is created, correct, the fuel in the carburetor will be sucked inside. Correct. You can see that the fuel which is stored in the carburetor using a float mechanism, maintain this one, that will enter into this Venturi. Correct. There's a small pipe, and with this one, and the fuel enters. So now already air is going. When the fuel comes, the fuel being petrol, we are using petrol, correct, or gasoline, which will easily evaporate. At room temperature itself, if petrol can evaporate, and the air is moving, rushing, correct, as it rushes, so it sucks the petrol, correct, through the Venturi from the carburetor, so using a small hole, correct. So the whole side is how much fuel can go, correct. So if the engine is moving fast, more air is sucked, more petrol is sucked inside, and the air and fuel get mixed up automatically, correct. It gets mixed up automatically, correct. So you can see here the fuel is coming, which yellow, but this is orange color. The air is, so it is small drop, correct, coming out of the Venturi from the carburetor. The controlled fuel. Who is controlled? Fuel is controlled by the carburetor. Controlled by carburetor. Right? So that depends on there is a small hole. What do you call a jet? They call it a small jet. Jet is not a small hole. Correct? And the whole size is already decided depending on how much fuel should go based on engine size, all those things. So carburetor design, they were taken care. The fuel, so now more air goes, more vacuum is created, more fuel be sucked inside, and it goes. Correct. So the quantity of air fuel going inside is controlled by this throttle valve. Correct. This throttle valve is controlled by driver. Right. If you press this one, more the valve opens, more air will be coming in. When more air comes in, more fuel will be sucked automatically because of vacuum, correct? And it mixes. Here goes air fuel mixture. Air fuel mixture enters in the engine. Of course, inside the engine you have spark plug, automatically the engine start working. Okay, start combustion. Then high pressure is created. Combustion happens. High pressure gas is created, and automatically everything is this. So this is the conventional carburetor. Correct. This is the conventional used for all petrol engines. All gasoline or petrol engines, right? Old generation, I say the old generation. Petrol engines use the carburetor for fuel metering, correct? The fuel metering means controlling, correct? So carburetor controls the amount of fuel because here there is a jet, I told you, correct? The jet size, there's a jet hole size. That is decided by the carburetor manufacturer. You have to select right carburetor for your engine, depending on how much fuel should go, so that you can maintain the air fuel ratio for your engine. Correct? That is the job of the engine designer. Okay. So this is how the carburetor works. So here, when I press the accelerator full, correct? The butterfly valve fully it becomes horizontal. Correct? The complete Venturi is the manifold is open, so more air can go in. Correct. When the engine is now, when you are not pressing the accelerator pedal, what will happen is this valve, correct? This valve will be horizontal, something like this, some angle. Correct. This is the throttle valve. So you can see that it stops airflow inside the engine. Correct. This is called 0% throttle. Correct. When you press the throttle 10%, if you apply the throttle, press it by driver fully, correct? Fully pressed condition, correct? Fully pressed condition, correct? This butterfly valve becomes straight, like already what is shown here, correct? It becomes like this. You see that it is vertically this one. So that means no restriction, all the air can go in, correct? So this is the full throttle condition, 10% throttle condition. When it is idle condition, zero throttle or idle condition, you start the engine. You don't put gear, and leave the engine to run without pressing the accelerator pedal, still you can see the engine will be running. They are called idle speed, correct? That is ideal speed condition. The engine may be running around 600 RPM, correct? If it is a car engine, multi-cylinder engine. If it is a single cylinder motorcycle, it can go to 1500 to 1700 RPM. Correct. So even there's no need to give accelerator, just kick start or button start to this one. So engine will be running at a low speed called ideal speed. That time the throttle is not 0%. It will be opened by maybe some 1 or 2%, 3%. We say that 0%, but 0% without air engine will not run. Correct. The throttle will be slightly open, some angle, little bit. So in the side there air can go. Correct. So 2% opening will be there. Some air can go. So when air is entering, automatically suck the fuel from the carburetor. Correct. So the throttle can open something around 2% at ideal condition to 10% full throttle or maximum speed, engine speed. That's how this is called fuel metering by this one. Okay. This has a lot of drawbacks as per the engine is concerned. Correct. As per the engine is concerned. Correct. In petrol engine, in the air fuel ratio, normal air fuel ratio, AFR, short form is called air fuel ratio, varies something from generally 10:1 to 25:1. Correct. That is latest engine. If old generation, you may go around 20:1 or 18:1. Correct, depending upon the engine manufacturer. Correct. So when the first number 10 is called air mass. The second value is called fuel mass. Correct. Together they form the air fuel mixture. Correct. So who is the air fuel mixture? Whether it is 10:1 or 10.5:1, 11:1, 15:1 or 16, 17, 18 or 20, it is controlled by the driver. How he is controlling? He is controlling using his accelerator pedal. You press it, or in motorcycle you have throttle right side. No, you turn the accelerator knob, right, which is fixed on the handlebar right side. When you turn, you are controlling this throttle valve, right? When throttle valve, generally throttle valve be fully closed, I said with less air, only for idle speed, then it turns. When you turn it becomes steady. So it varies from, for example, 0 degree to 90 degree. 0 degrees when throttle was fully closed, horizontally, correct, like this. There no air can go in. When you press full percent, correct, 90 degrees, that is 10% throttle, correct. The throttle valve will become steady. That means no air restriction. All the air coming from atmosphere can go inside when the vacuum is created by when the piston is moving down, correct. So air. This happens in the suction inlet. When the inlet valve opens. Correct. Inlet valve opens. When it opens during the suction stroke. Right. There are, if you have done the course on IC engine, you know that there are two-stroke engine, four-stroke engine. I am talking where nowadays two-stroke engine almost is already banned. Nobody worldwide it is not allowed except very special applications. Previously it was there, but now all the petrol engines are four-stroke engines. There are four-stroke called suction, compression, combustion, and exhaust. During suction stroke, this inlet valve opens, so the piston starts going down. Correct, piston starts going down because it is connected to crankshaft. Correct. So in the combustion chamber, vacuum is created. Correct, vacuum is created because the piston is going down. So the air is sucked in. Depending upon the throttle position of the driver demand, whether driver wants more torque or less torque, he presses accelerator pedal. According to this butterfly valve opens. Fully closed condition is horizontal. Correct. No air can go except little air for idle speed. Correct. Engine to run. Otherwise, it can become vertically this one 90 degree when throttle is fully open. So the fuel quantity is controlled by the driver by pressing this accelerator pedal, by which he controls the air quantity. Correct. Please note that he controls only air quantity by controlling throttle valve. Correct. Throttle valve opens or closed depending on air is entering. Correct. But fuel is not controlled. Of course, fuel is also controlled when the butterfly valve is connected to one needle valve in the carburetor. Correct. So that opens the fuel quantity. There's a small valve, they call needle valve, which opens the jet opening. So the fuel amount of fuel coming from the carburetor to the venturi part of the this one, where it mixes with air is controlled. So the air-fuel ratio is controlled by carburetor, in the carburetor by the driver. Correct. So, but it has a lot of drawbacks. In the cold conditions, in the carburetor system, in cold climate, or cold climate means it can happen, correct? You know that in some countries cold, especially you go to US, Europe, or North India, all those things, in winter, the morning temperature can become 0 degree or lesser than that, correct? When the air is very cold, even if you start the engine, air is coming in, correct? When you press the accelerator, this valve opens, correct? Air enters the cylinder, but then because of the vacuum is created, when air is flowing through the venturi, vacuum is created, this liquid, because you know the petrol is in liquid state, correct? Petrol is in the liquid state stored in the tank, correct, which is coming to the carburetor. Though the liquid will be sucked in, but it will not evaporate because the air temperature is very low, 0 degree, correct? If fuel is not evaporated, if fuel has to combustion, if the combustion has to start the petrol engine, the fuel should evaporate and become a mixture, correct? Fuel gas vapor, petrol vapor. It should become petrol vapor. It should be vaporized. But when temperature is 0 degree, sub-zero, or close to this 5 degree, all those things in winter, the fuel will not vaporize. So if it is not vaporized, combustion cannot, even if you give a spark, combustion will not start. And fuel, because that is a starting trouble, correct? So in that case, what you have to do is you have to inject less fuel, correct? You have to inject less fuel. In carburetor, there's no such thing available. Instead of that, what they do is you have the choke valve. You can see here there is a choke valve. In motorcycle, you will see on small choke, correct? Your lever will be there near the throttle control. You close the R in the carburetor itself, correct? In the carburetor itself, there will be a small lever, and if you close it, what happens is the amount of air coming in will be reduced, because normally this will be like this. When you close the choke, this will be closed like only a small amount of air can come in, correct? It controls the, so for less amount of the air, you are injecting same amount, more amount of fuel, correct? Then you say that the air-fuel ratio improves, correct? So that means more vapor for less air. So then engine, so they called choke control, correct? So you do this. That's how you control the engine starting using the choke lever, correct? What do you do in choke lever? When you close the choke lever, normally in ideal condition, without giving throttle, for example, say X gram of fuel is air is going, X gram of air is going without the choke control. When I close the choke valve, this air, correct? This will be reduced, correct? So it may become say 0.5 times of X value, correct? So this is air going in. Then, but fuel quantity is same because throttle opened by the driver, correct? An ideal condition already open, so the amount of fuel coming to a carburetor will be same. So that means less air, more fuel. Then the air-fuel AF ratio increases. So engine can start. That is the choke control. Okay. Because of this, the fuel quantity cannot be controlled. There are other issues. Correct. We don't have much time to talk about it. These are drawbacks. Correct. So choke control. Then when the fuel is coming as a correct, it is in the liquid form. Correct. In the carburetor liquid will be sucked in through the jet valve, correct? Right, small jet valve, correct? Then you can see that is droplets, correct? The petrol will be in the form of droplets, which is nothing but liquid droplets, correct? From the carburetor, it is sucked as a liquid, and it breaks down to small liquid droplets. Now, as it is going inside the engine along with air, depending upon air temperature, correct? The liquid petrol droplets, correct? This is liquid droplet, nothing petrol droplet will evaporate, correct? Based on the temperature of the air, and by the time it enters in the cylinder, it becomes a air-fuel mixture, correct? As a vapor, petrol becomes vapor, and it mixes, correct? So it should mix, and inside the cylinder it should be completely filled. Air with the fuel, correct? Air with fuel, correct? Will be mixed. That is fuel molecules in the gas form. in gaseous form, right? Once inside cylinder, the liquid droplet which was going inside the engine through the manifold, by the time it reaches inside the combustion chamber, it should become a gas. That means it should be evaporated. Then only it can mix with air, correct? It can mix with air and form what you call as a homogeneous air fuel ratio. Homogeneous air fuel mixture. That means air and this petrol, gasoline molecules are evenly distributed, which is called as homogeneous mixture, not to concentrate one area, correct? So that will happen only if the fuel is fully evaporated. Petrol is this one. But in cold condition, this doesn't happen. That is the problem, correct? It is not because it is entering as a fuel, liquid fuel, and because of the air velocity, the liquid petrol is broken into droplets, liquid droplets. That droplets is bigger. If the air temperature is less in the winter condition, then all the fuel will not evaporate and become a gas. If it doesn't become a gas form, the petrol is not become a gaseous form because of evaporation not happen in winter condition. Homogeneous air fuel ratio will not happen. If it doesn't happen, then what will happen is all the fuel will not be burned. Correct? The fuel which become a gaseous form will mix with air and will burn and produce the force. Correct? Force is generated. Correct? Pushing down the piston, which is converted to torque, and in the crank mechanism that is connected to V. Correct? But less fuel, since doing to low temperature, less fuel in the coming out of the carburetor is evaporated in the winter condition. So the all fuel is not mixed. Correct? So some fuel will be in the liquid state. Liquid fuel will not burn fully. Correct? Liquid fuel will not burn. Liquid fuel never burns. Any fuel in liquid form will not burn. Even when petrol, if you put a flame near it, first the petrol should become evaporate, correct, as a gas, vapor. That vapor will mix with the air surrounding it, so that the oxygen, because for combustion you need oxygen, correct? It should mix. That's how it happens. Even if you have a liquid fuel, correct, with any fuel, the top layer will evaporate, correct? They will evaporate, correct? Evaporate and mix with the oxygen, O2, and sufficient temperature pressure is there, combustion happens. Correct? So, but no, combustion happens layer by layer only. Correct? So, but before entering into the combustion chamber, if the fuel droplets are completely evaporated, already become a gaseous form. Correct? Fuel vapor. Instead of fuel droplets, it become fuel vapor, and it can easily mix with the O2 and evenly distribute inside the combustion chamber, which is called a homogeneous. Then when you give a spark, the flame starts and the fuel will evaporate in proper this one evenly, and it will produce force. Linear force is generated properly. That all fuel burns means then you will get more force. This force is converted into torque by the crank mechanism. Correct? Crankshaft mechanism. So which drives the vehicle wheels. This one. That's how the carburetor works. But the problem is in winter condition, the homogeneous mixture doesn't happen because the liquid will not evaporate. Liquid droplets coming out of the carburetor will not evaporate because temperature is not the air temperature. Which controls the air temperature? Air temperature controls whether homogeneous mixture happens or not. Correct? In summer, no problem. Correct? In Delhi, summer morning temperature, early morning temperature maybe 30 degree. Night temperature also 25 degree. But in winter, it becomes 0 degree, minus degree. Correct? Southern part. You go to Russia, Alaska, in US, correct? European country, Netherlands, Sweden. Most of the almost 68 months, you see that very cold temperature. Right? Daytime also, morning will be so. So this homogeneous mixture doesn't happen. That is the major problem of the carburetor. Correct? So how to solve that? For that only they were doing research. Universities and engineers across automobile company, they came with fuel injection system. Okay. What is the advantage of this one? In this case, you can see that there is an injector. This is nothing but an injector, fuel injector. Right? Fuel injection sprays the fuel. Okay. You see that this is my petrol tank, fuel tank. From there, the fuel is coming. Yellow color is shown here, correct? So yellow color is not, sorry. So yellow color is nothing but fuel, correct? From the tank, it is connected, is coming. So through a pipe, but it doesn't come directly. There's in between, there's a pump. Okay, there's a different color. The fuel coming from the petrol tank is connected to fuel pump. 1 minute, I will just stop it. I know that time is up. I just is last right. Fuel pump. Fuel pump pressurizes the fuel. Right? The what fuel? Petrol fuel. Correct? We have petrol. Petrol as the fuel. From the tank, fuel comes to the pump. This is my pump. Correct? The pump pressurizes fuel up to 5 watt pressure in what you call PFI, port fuel injection system. We are going to see tomorrow. The fuel is pressurized to 5 to 6 bar pressure. Correct? Normally, the fuel at atmosphere is at 1 bar pressure. There's air pressure. Correct? So now the fuel is pressurized by pump up to 5 bar. That pressurized fuel is coming to the injector. Correct? And comes and waits here. You can see here there's a jet valve. There is a small jet. Yeah, I will remove this. We can see it. Just 2 minutes, I will close it. I know that you may have next class. So you have your correct. This is valve. Right? This is valve. You can see there's a small one. This is connected to, this is the coils, correct? Electric coils, correct? And you have, this is called as plunger. Correct? The whole part is called plunger and it is spring loaded. So generally the spring pulls the plunger down, which the plunger is connected to a sharp wedge like thing. This is called a needle valve, correct? So the needle valve is here. Correct? This part I'm showing, correct? So needle was here. This is normally held down. This is held down by the spring, correct? This spring, correct? So now, if you give a electric voltage to this coil, correct? You apply, say for example, 12 volts. Current flows, correct? I flows. This valve creates electromagnet, correct? The electromagnet pulls the plunger up, correct? So the this goes up. There's something like this, correct? The high pressure fuel can come in, correct? Fuel comes as a jet, correct? So 5 bar pressure, 5 to 6 bar pressurized fuel comes out through the jet, the small nozzle, which is called jet, correct? In injector. So what will happen? The liquid fuel becomes small droplets. When you inject, if you allow the fuel to go out a small hole, correct, and go to opening at high pressure, here the 5 to 6 bar, what will happen? Liquid will break into small droplets. The droplet size will be in the order of micrometers, maybe say 50 to 100 micrometers. Diameter, correct? The droplet diameter becomes small. Now, in the carburetor, the droplet size will be in the order of 500 to maybe 100 subdiameter. For example, 200 to 600 micrometers, bigger droplets. So they don't evaporate. But when you pressurize through the pump and allow the fuel to come out in a small nozzle in the jet at high pressure, the droplet size becomes smaller. I told you, say for example, 5 to say 20 micrometer, so 20 micrometers, something like that. Smaller size, correct? So now that is entering into the air, correct? What will happen? That will become easily evaporate. So if the droplet is small, then fuel will evaporate quickly and then it will vaporize. So then it forms homogeneous mixture. Okay, so that's what is mentioned. These are the advantage of fuel injection system. I will stop here. So better fuel evaporation we will see tomorrow. Correct. Thank you. Tomorrow 8 o'clock will be.